Good afternoon, ladies and gentlemen. Thanks for YouTube on Google for exposing me to 19 countries on my video blog. Good afternoon, guys. I am Professor David J. De Los Reyes, an electrical engineer by profession. Had been a professor for not so long a time, but it could be a long time also. So this afternoon, my topic will be a new discussion on my channel, and the topic is differential equation. This is now my third complete course, which I am lecturing, okay? And I am now on lesson number 18. Okay, let's proceed, guys. I am now on lesson number DE number 18 under the course differential equation on my channel, Professor David J. De Los Reyes. And the topic under the differential equation is homogeneous differential equation. I think this is now example number 3. Example number 3. I'll give you variation of problems that the differential equation is homogeneous. And I think this is example number 3. Okay, let's proceed. The topic for this afternoon is the solution of a homogeneous differential equation. Example number 3. Okay, let's proceed. We are given the differential equation. I will read it, guys. X cotangent of y over x minus y close bracket dx plus x dy equal to 0. The problem is asking what will be the relation of x as a function of y. So it could be the general solution supposed to be. General solution because we are not given initial condition, so we do not have a chance to compute for the so-called constant of integration. So the problem is asking for x as a function of y, general solution. The topic is homogeneous differential equation. Okay, let's proceed. I will let the substitution y equal to bx. This is one of the options under homogeneous. I will choose this one. Okay? I will let y equal to bx. dy, taking the differential of both sides. Product, right? First function, differential of the second, plus the second, differential of the first. Or dy is just simply b dx plus x dv. We will take this value here and this value here. We put it on the original homogeneous differential equation. Supposed to be it is homogeneous. So I place it here substituting. We are following this. It is x cotangent of y over x. But y is bx, so this should be bx over x, close quantity, minus y. Minus y minus bx, close bracket dx. I am following this. Plus x times the equivalent of dy in terms of x and dv, that is actually b dx plus x dv equal to 0. We are now through with the substitution, so we will manipulate using algebraic manipulation, expand. So what will come out will be x cotangent of b. Bx over x, it will just be simply b. X will cancel out. Minus bx, close quantity dx. We will expand this one, so this should be bx dx plus x squared dv equal to 0. Expanding further, x cotangent of b dx, I'm expanding this one, minus bx dx. I will rewrite this two here, so this is bx dx plus x squared dv equal to 0. And luckily, try to combine similar terms. This is a minus bx dx. This is a bx dx. So they will try to cancel out each other. Right? Simplifying further. X cotangent of b dx equal to, I will transpose this one on the right. So this should be negative x squared dv. So actually what comes out is a combination of x and dv term. Okay? So, to integrate, we must have to separate the variables. Because according to the solution of homogeneous, after the substitution, what will come out, whether we like it or not, will be a variable separable differential equation. And to do that, do some algebraic manipulations. So I will rewrite this one. Then I will multiply all the terms by 1 over x squared cotangent of b. Right? Bracket, bracket, this bracket, I will multiply, then I will expand. X cotangent of b dx is this, times 1 over x squared cotangent of b, but it can be written as the product of x times x cotangent of b. Okay? This x squared, I wrote it as simply x times x, equal to negative x squared dv. On the right hand side, I will still place this one, right? So this will be x squared cotangent of b. Why I put the terms under the denominator under the parentheses? So I could cancel out. I could show the cancellations. Okay? This x here cancel with this. Right? This cotangent of b cancel with this. So what will remain on the left will be dx over x. This is dx over x. On the right hand side, this is negative x squared, right? But it can be written as simply negative 1 times x squared, right? Because negative 1 times x squared will be negative x squared. This is the operation is multiplication. Guys, bloggers who do not know how to cancel, this is the proper way how to cancel terms. If the operation is multiplication, you could cancel out. So this is x squared, right? So what will come out on the right hand side will be negative 1 times dv, it will be negative dv over cotangent of b. So as you notice it, the left hand side is now a pure x term, and the right hand side is now a pure dv term. So actually, we already have separated the variables. Okay? So it is true that according to the solution of homogeneous, after the substitution, what will come out will be a variable separable differential equation. This is now a variable separable differential equation. Okay? To bring out the solution, integrate. Okay? But we try to manipulate first for it to be integrable. This is dx over x. 1 over cotangent is tangent. I place it here. 1 over cotangent is tangent. So I could replace 1 over cotangent by tangent, then times dv. So what will come out will be dx over x. And again, I could replace tangent. Tangent is the ratio of sine over cosine, right? So I could replace tangent by minus sine b over cosine of b dv. Because I am thinking of the natural logarithm solution. Okay? So what will come out? Try to integrate now. Integrate. The integral of dx over x equal to the integral of negative sine of b dv over cosine of b. This is under natural logarithm supposed to be. Right hand side, it is still under natural logarithm, but we must have to verify. For the first one, the value of u is x, du is dx, it is exact. This is dx, this is dx, exact. Right? Left hand side, right hand side, the value of u is cosine of b. Taking the differential of both sides, du will be the derivative of a cosine is negative sine times its differential. So it will be negative sine of b dv. This term here is exact. It is same as this one. Okay? So the left hand side will be under the natural logarithm, and the right hand side rather will be under the natural logarithm also. Okay, after the verification. So what will come out on the left hand side now will be, since the verification is exact, this is exact, it will be natural logarithm of x. Right hand side, natural logarithm of cosine of b plus a constant of integration. We will place it here, but I could replace the natural logarithm sign. There's no problem over there because the natural logarithm of c is still a constant. Okay? because I was thinking of compressing the right hand side. Therefore, the natural logarithm of x equal to the natural logarithm. The natural logarithm of is half is actually 1 under natural logarithm sign, and it is expressed as a product. So natural logarithm of x equal to the natural logarithm of c cosine of b. There is a natural logarithm, there is a natural logarithm, so to free the left and right of the natural logarithm, take the antilog of both sides. And under natural logarithm, the proper way on how to take the antilog is simply written as e raised to the natural logarithm of x equal to e raised to the natural logarithm of the product c cosine of b. And the antilog of the natural logarithm of the given function is just the given function. So what will come out on the left will be x equal to c cosine of b, but b is actually x over y, or y over x. Y over x. Sorry for this one, guys. It should be y over x. So we could replace this b here by the ratio y over x. So our final general solution will be x equals to c cosine of y over x. That is our final answer. Okay? Oh, that's it, guys. Oh, that's the solution of a homogeneous differential equation. The problem is actually on the integration. If going to the integration process, you cannot integrate it, that's your problem. That's why in my discussion at the start of differential and integral calculus, I saturated you with problems on differentiation and integration. There must be no reason why you cannot differentiate and integrate. Because under differential equation, if you do not know how to differentiate and you do not know how to integrate, you're gone. So actually, the prerequisite of a differential equation is differential calculus, integral calculus, plus your knowledge of trigonometry and algebra. That's differential equation. So our topic for this afternoon is the solution of a differential equation homogeneous, example number 3. The final answer is x equal to c cosine of the ratio y over x. That is our general solution. Good afternoon, 19 countries that is watching me right now. Thank you. This is Professor David J. De Los Reyes from Los Angeles. Good afternoon.